Hello friends, welcome to our channel Knowledge Amplifier. So today we are back with another interesting video tutorial related to SnowPark, which is one of the latest and powerful release of Snowflake, where using your favorite language you can do all the different kind of extract, transform, load, etc. instead of only relying on SQL, right? Although in backend actually it converts all the data frame transformation into SQL only, which we have already seen in our previous video. So before going ahead with today's discussion, I will request you to go through our first video of SnowPark if you have not seen that, because that video will surely help you to understand today's topic in a much clearer manner. So today what we are going to discuss is basically we are having an external stage pointing to a folder within a S3 bucket in our AWS account. And now what we'll do, we will put some data in it, and if we have to load the external stage data in a Snowflake table, then either we execute copy command, or maybe what we do, we point an external table to that external stage and then we execute alter refresh command. This way we load the data from external stage to Snowflake, right? So now today in this particular video, we will try to read the data from external stage in a SnowPark data frame, and that data frame data we will try to write in our Snowflake table. Okay, that's the experiment what we are going to do. So for that, here I have taken some sample CSV file which is belonging to ID's dataset. Let me show you one structure. It is having ID column, sepallength, sepalwidth, petallength, petalwidth, and class. Okay, what generally we are having in our ID's dataset, right? And the same structure is followed for varchar and varchar, these two files as well. First column is integer type, next 4 columns are double type, and last column is basically varchar type. Okay, so what I will do first to start the demo, first I will load only one file in our external stage. Okay, so here we will upload. So here it is uploaded. Fine. Now what we will do, we will go to our Snowflake worksheet, and then here we will execute some codes which I will be sharing in the description box or in the comment section also. So as a first step, we are dropping a database if it exists. We are creating the database for this demo, and we are using this particular database. Here I am creating a table. This is optional, we are not going to use this much, but if you want you can execute this. So here what we are doing, we are creating a table having name video, and it is having this kind of schema. Okay, this is not required for our project. File format also is kind of optional, but these things already I executed in our previous video, so just executing, right? And now here external stage we are creating. So you see that URL, first I am providing the bucket name ID setup. So if you see our bucket name is ID setup, within that we are having a folder with the name ext stage testing, right? So that one only we are doing URL s3/id setup/external stage testing. And to set up the integration between Snowflake and S3, we are using access key and secret key based authentication, but we can go with IAM role based authentication also, not a problem, what we discussed in our previous video. Okay. Now here if we execute list command to this particular external stage just to make sure the integration is working, we should see this particular file it has detected. Okay, so let's execute. So see here setusa.csv, this file size md5 has and last modified everything it has detected. Okay, right? So now we are having an external stage pointing to an S3 location. Now obviously we can execute copy into command to load the data from external stage to this particular video table. That is fine. I am not going to that. Now let me go to SnowPark discussion. Okay. So here what we are going to do first, we are going to read the external stage data in a data frame. It is just like in PySpark from S3 you are reading some data, right? But here this time we are going to use SnowPark. So what are the changes available that we have to understand. Okay. So here what we are doing, we are doing all the necessary imports, and then here connection parameter we are configuring. Here I have not given user ID password. So let me just set up the connection quickly. So here I will write Python, and then here import the SnowPark session, and from SnowPark functions everything I am importing. The second command is just like from pyspark.sql.functions import star. And now here what we are doing, in connection string I will be providing the user ID and password, and I will execute that. So I have already configured the connection parameter earlier, which I could not show you due to security purpose. And now here what we are doing, creating the session. If your connection strings are correct, then this section will be created smoothly, or else it will throw an error. Okay. So see, it went to next line. That means it is correct. Now to read the data from external stage, this is the command. What we are doing? See, it is just like PySpark command. Suppose you have to read some data in a PySpark data frame, and which is CSV data. What you do? You write spark.read.csv, like that way, right? So that same way, session.read.csv. And now here to read the CSV data, what we have to do? We have to mention the external stage location or path where the data is sitting. So SnowSimple is what? SnowSimple, if you see that this is our external stage name. So we have to use the external stage to get access of our S3 data. So ramu.public I am using, which is mentioning the database name and the schema name. Okay. So here I can execute this particular command. What it will do? It will go to our external stage SnowSimple. Whatever CSV data is there, it will try to read. As simple as that. Okay. So here see, we are getting an error now. What is this error? In Spark, if you recall, this kind of code generally work. That spark.read.csv. But in Snowflake, it is not working. And the exception it is throwing that you must call dataframeReader.schema and specify this schema for the file. Okay, so what it is saying that if you try to read the data from external stage using SnowPark, you must have to mention the schema of the file. So let's do that. So here what we are doing, we are defining the schema. So for schema definition, here we are importing different types, right? So here see, all are showing in red color. Why? Because the types component we have not imported. So it is just like PySpark, what we do from PySpark.sql.types import star. So here we need to do from snowflake.snowpark.types. Okay, import star. So let's execute that. As soon as we execute this, you see all the errors are gone. And here we are defining the schema for our CSV file. If you recall, here our ID column is integer type. So here you see that ID is integer type and nullability property I have kept true. You can make it false also, not a problem. Now sepallength, sepalwidth, petallength, petalwidth. These all four are double type column. And the last column is varchar or string type. So here I have kept string type, right? So here what I will do, I will create the schema. And as a next step, I will read the data. But before executing this line, we will observe what is happening in our query history also. So for that, what I will do, I will just execute a dummy query, because in our query history already multiple queries are there. So we might get confused from where we need to check what are the queries executed against a data frame operation. So for that, what I will do, I will execute a dummy query, select start from video. Although we know it will be empty because in this particular table, we have not executed copy command, right? Now if we go to query history and refresh, here you see that select start from video, this particular query is available. So after this particular query, whatever query will come, that is basically due to the data frame operation, what we are going to do. As simple as that. So here we are doing a read. Let's see whether anything is happening or not. So see, nothing happened. Why? Because SnowPark follows lazy evaluation. So until and unless you are calling some action, it will not do that operation, right? So let's do that. Iris flower read.show. So here it is just like df.show. Here we are reading the data. So here see, it thrown an error. What is that? Numeric value ID is not recognized. So I will come to that, but before that, let's see what is happening in our Snowflake query history. So select start from video was our reference query, and now if I refresh this dashboard, anything will appear after select start from video or above select start from video is due to data frame read operation, right? So once I refreshed, I got 3 comments. What it is doing? See. First, it is creating a file format, which is mentioning that it is a CSV file format. And then here, if you see this particular select query, it is basically going to our external stage and using the temporary file format what it has created, it is trying to select the data. But this particular operation is getting failed. Now the question is why it is failed. The reason is, if you observe this particular file, this file is having a header, right? And now you are defining this schema like ID should be integer type, sepallength should be double type, etc, right? But the CSV file format what it is getting created, it has not mentioned anywhere that the first row you should ignore because that is header. So due to that, what is happening? that the Snowflake is considering first row also as data element and trying to impose the schema what we have already configured in the schema part in the SnowPark, right? Now you consider ID. For ID, if suppose SnowPark is considering as a value and ID is string, you can understand. But for here in this schema, we have defined ID is integer type. That's why it is throwing an error, because in integer type column, this kind of string data is not possible. So whatever this file format temporarily this SnowPark is creating, we have to make sure that SnowPark create with header true. That is, it will understand that the first row has to be ignored because first row is header. So for that, what we need to do? We need to add one option parameter. So if you recall in our PySpark, when we read the data, we have multiple options, right? So here also you can pass the options. So here you see what we are doing, session.read.options, and here we are passing different options, and these options will be used while creating this particular temporary file format. Okay, and that one will be used in the next step to read the data from external stage in the backend using the select query. So let's observe what we have written, session.read.option field delimiter comma, because this is a comma separated file. Skip header 1. Okay, right? So this will resolve our earlier problem, and we are mentioning the schema and we are reading the CSV file. So now let's run this. So we have ran that, but you will observe that nothing happened because it follows lazy evaluation. So see, no new row came in query history. Now to understand what is happening, I will execute the reference query, select start from video. So now here if I refresh the query history, I'll be getting that here. So anything appearing after or above the select start from video is nothing but due to execution of this command. Okay. So now let me do id star read.show. Okay. So here see, now it has given us some data. That means it is perfectly working. Let's go back to our Snowflake console and refresh the query history. Anything after the select start from video, what are those? These three code, let us try to understand. So see, first here again we are creating temporary file format. But earlier while creating temporary file format, these two options was not there. Field delimiter comma and skip header 1. Okay, this is the interesting part. And that's why in the select query it is not throwing an error. And then once that is done, it is dropping that temporary file format whatever it has created. So this is 3-step operation whenever you are reading CSV data from external stage. Okay, right? I hope you got it. Now let's come to the next important part, that many times while loading the data, we might have bad data in the external stage. Let me show you such data in another file. So if you consider the varchar.csv file, here you see the petal length column, we are telling that it is a double type column. That is fine. But you see this element, this is basically string type data. In the double type column, string type data is present. So it might fail, right? So let's see what happens in reading the data. So what I will do, I will load this particular error file also in our external stage and we'll try to read the data from our SnowPark. Okay. So this file is uploaded. Now here what we are doing, we are reading the data, right? As we did earlier also, no change. So here I will execute this command. If I execute this command, again in the backend, after drop file format, again 3 same kind of queries will be executed if you see. Okay, here I have not used dot show, so it will not execute. So before showing dot show, let me just do select start from video. So nothing is there. Let me refresh. So select start from video came. So this will act as a reference query. Anything appearing after this is due to this command. So here we are doing dot show. So here see, it has not thrown any exception. Why? Although in petal length we have a string type data, and in this schema we are mentioning that petal length column should be double type, but still while reading the data we have not got any error. Why? So let's see the query history, we will understand that. So see, after select start from video, again same 3 queries. First it created the temporary file format with field delimiter comma and skip header 1, and it tried to read the data and then it is dropping the file format which it created temporarily. Okay, observe the select query. Because we are using dot show, so it is just doing limit 10, and this particular error record, okay, what we are having, that is having at line number 13. That's why this particular error is not getting detected. Suppose you are reading a bigger chunk of data, then the problem will appear. Let's see that id is flowerdiv.show. So if I am executing that, here you will see that it is throwing an exception clearly. Numeric value 4.hello2 is not recognized. Why this is happening? This is happening because of this particular one. Now if you recall our copy command, while we discussed, that time we faced this kind of challenges. And that time we had an option, if error occurs, we can avoid the error and we can continue loading the correct data. And that key value pair was on error equal to continue. So let's use that now. So here also, while reading the data from external stage, you can mention on error equal to continue, which will avoid all the bad records and load the correct data. Okay. Here we are mentioning the schema and this CSV data we are reading from external stage. Okay, right? So I will execute this. And here what I will do a select start from video just to use this as reference query again in our query history to avoid confusion. So see, select start from video appeared. So anything after this particular select query is nothing but due to this particular execution. Okay. So now what I will do, I will execute .show command with 1000 records. So for the same command earlier, when we have not used on error equal to continue, we got exception due to that particular bad data. But now let's see whether we are getting that or not. So let's execute .show. So here see, it worked perfectly fine. That means it ignored that bad data and loaded all the good data. So what are the queries executed in the backend? Let us try to understand. So if I refresh this particular query history, here you will see now this time 4 queries are executed. Earlier if you observe that every time 3 queries are executed, one is on the fly, it is creating a temporary file format. Then in a select query, it is using that file format and then it is dropping the file format. But this time it is executed 4-step process. So as a first step, it is doing a create or replace temporary table. And in the temporary table, it is executing a copy into command with on error equal to continue. Okay. So whenever in SnowPark you are using on error equal to continue, in the backend, it is using that copy into algorithm only. Okay. So that's how the Snowflake backend is created. That is, they are reusing the algorithm for on error equal to continue part in the SnowPark also. So here, what is the first step? First step, they are creating a temporary table in create or replace manner. Then they are doing a copy into command from that external stage to that temporary table with on error equal to continue and the file format and skip header, all these properties, and force equal to true. Okay. Now in the next step, what they are doing, from that particular temporary table, what they have created, they are executing a select query and that data they are returning us in the data frame. Okay. Now what is the last step? Obviously, last step is dropping or deleting that particular temporary table what it has created. So it is executing the drop command. Okay, right? So I hope you got it. Whenever we are using on error equal to continue while reading the CSV data from external stage, it is a 4-step process. Step 1, it will execute a create or replace temporary table. Then it will copy the data in the temporary table from external stage using on error equal to continue. And in the next step, it will select the data from that particular temporary table and it will return in the data frame. And in the 4th step, it will drop that temporary table. Okay, right? It is not creating any file format like earlier. Why? Because in the copy into command only, all the file format property like type equal to CSV, field delimiter, comma, skip header 1, whatever we have mentioned, all these are coming in the copy into command only. So everything is handled there itself. Okay, right? So I hope you got it. Now what we will do, we will refresh this particular page, and before going to next experiment, let me again execute select start from video to use that as reference query. So here if you see select start from video is there. Now what I will do, earlier already we have read the data and view it using .show. Now let's execute .count. Suppose I want to get count of records including those 2 CSV files. So let's hit and enter. And here you will get the result as 100. Why 100? If you observe a Setosa file, if I just put my mouse pointer on top of a column, here see count is 51. Ignore the first row because first row is header. So count of rows in the Setosa file is 50. Let's go to the next file and let's see. In the versicolor file also, if you observe, the count is coming as 52. out of 52 rows, first row is header, so this we should not consider, and this row has error, so this also we should avoid. So 52 minus 2, it is having basically 50 records, right? So in varchar 50 correct records, in setosa 50 correct records, so total 100 count it is returning, which is perfect. So now let's see what query it has executed when I executed dot count on our data frame data. So any query appearing after select star from video is due to that count operation. So let's execute that, and here you see that first what we are doing, again that same process. First we are creating a temporary table, then we are executing a copy into command based on error equal to continue. Then on top of that temporary table we are applying count one operation, and then we are dropping the temporary table. That's how it is working. Okay, fine. Suppose next time again I am executing iris flower leaf dot count. Let's see what happens. Okay, so for that let me again execute select star from video query for reference purpose, and if I refresh, here this code came. So again I am executing for example count, and here you will see again it returned 100 obviously. And if I go back to Snowflake and if I refresh, here you will see that again that four set of queries. First creating the temporary table, then executing copy into command, then from the temporary table execute select count of one command to get the count. Okay, so now you can easily understand that this is not an efficient approach. Whenever I am applying any transformation, all these queries are executed in the backend. Although same query I am executing, but still it is executing this kind of four set of operation in the backend. And especially if you consider the copy into command, this is heavy operation, because suppose think like this way, in your external stage you are having huge volume of data. Again and again if you are executing copy into command, obviously it is going to take time as well as it is going to increase the cost, right? So what we can do, we can cache the data just like PySpark to avoid again and again computation. So here to cache the result set, you can execute this kind of command, ms equal to iris flower read dot cache result. Okay, so let me do that. So here I have done. Now here last query was drop table. If I refresh, here see some set of command got executed whenever we have executed this cache result, because cache result is basically an action. So let's see what queries are executed. Okay, so our reference query was drop table if exist. Now anything appeared after that are due to the cache result property. So here what we are doing, first we are creating a temporary table, and then there we are executing a copy into command. Up to this it is same like earlier. Now here if you observe, we are creating another table, and the difference is the first table, or in earlier case whenever we executed without caching data, the tables whatever got created, that was create or replace temporary table. Okay, now when you are caching the data, here what is happening, first it is doing create or replace temporary table, and it is copying the data from external stage to that table, and it is creating another temporary table, but it is not in create or replace manner. It is just a create temporary table. Okay, so it is nothing but storing our cache data. It is not executing create or replace. So cache data will not be automatically refreshed every time. Whatever data it is having as of current execution, it is storing that in a temporary table, and it is not using dot replace command so that the table will not be replaced. As simple as that. And the result set or data whatever stored in this particular temporary table can be reused. Okay, now this particular temporary table we have created, but here data is not there, so we are inserting the data from our first temporary table, which is created using create or replace command, to this particular table which we have created due to caching the data using only create table command. Okay, right? And then we are dropping our first temporary table which is created using create or replace command here. Drop table if exist, temp table, fqmh. Fqmh is what? Fqmh table is this particular one. If you observe, the first temporary table which got created using create or replace command, right? That table it is dropping. So here what is happening, in this particular temporary table our data is captured. Now if you execute count operation on this particular cached result set, it will not execute all four commands again and again. If you see, if I refresh this particular one, here you will see only one query it is executing, select count one from our temporary table which we created while caching. That's all. Okay. You can execute multiple times, not a problem. So here if I refresh, here you will observe again same query it is executing and it is reading from cache data. So just a quick recap. So here if we are using this kind of syntax where we are not using on error equal to continue, what are the 3-step process it is working? First, it is creating a temporary file format on the fly and it is using that particular file format to select the data directly from the external stage and it is returning the result set in the data frame. Okay, right? Now suppose we are using on error equal to continue, then what is happening? It is creating a temporary table first. In the temporary table, it is doing a copy into command execution with on error equal to continue property and then it is selecting the data from that particular temporary table and then it is dropping the temporary table. That's the process in this particular case. And if you are caching the result set, what it is doing? First, it is creating a temporary table and then it is basically executing a copy into command to load the data in the temporary table from external stage. As part of next step, it is creating another temporary table and in that particular temporary table, it is loading the data from the earlier temporary table and it is dropping the earlier temporary table. But whatever second temporary table got created, it is not dropping and it is keeping for cache purpose. Okay, right? As simple as that. Now, the last step what we are going to discuss today in this particular video is writing the data after reading it from S3 external stage. That is basically loading the data in Snowflake. Now we are going to observe. So if we try to load the data using SQL Code, what we do? We simply execute copy into command. So in SnowPark, what we are doing? We are reading the data in a data frame and we are writing the data in a particular Snowflake table. As simple as that. Okay. So before executing that query, let me execute select start from video. Here see, it is executed. And if I refresh, here select start from video, this one we can use as reference query. Now here, the save as table, the table name I can keep video only, or maybe let me keep some other table name. So you will see that on the fly it is creating the table also. So what we are doing here, this data frame data we are writing in this particular Snowflake table in overwrite manner. How to write SnowPark data frame data in a Snowflake table already I discussed in my previous video. So same command we are using. So iris flower did. This one we are reading using this on error equal to continue property, right? So here if we are executing this particular action, what are the queries we should be getting in the backend? Just think, like here if you observe, first we are using on error equal to continue. So first it will create a temporary table in create or replace manner. Then it will execute a copy into command. Then it will apply a select query on the temporary table and get the data in this particular data frame. Then it will drop that particular temporary table. And after dropping the temporary table, the write operation will start. So in the write operation, what it will do? It will execute create or replace process data table. Because here we are executing overwrite mode. So always it will be create or replace command for destination. And then it will insert the data in it. Okay. So here let's run it. So here it ran successfully. Now anything appearing above select start from video is due to that write operation. Okay. So see here, first it has created the temporary table and then it copied the content from external stage to the temporary table. Okay. Then here it has created a table using create or replace command process data, whatever table name we have provided here basically, right? And then it inserted the data from our temporary table what was created earlier where copy command was executed. From there it inserted the data in process data table and then finally it is dropping the temporary table where initially we executed copy command. As simple as that. And now if you execute select star from process data, here you will get the data. Okay, so this way using SnowPark you can read the CSV file from S3 location and write in a Snowflake table. Okay, obviously you can follow append manner also. So suppose in append manner we are trying to write the data in process data one table. So what are the codes will be executed? First it will create a temporary table, then it will execute a copy into command. Then here append manner we are executing, right? So if you recall, while using append manner, it follows several steps. First it will check whether this table existing or not using show table command. And if the table is not existing, it will create this particular table and then it will insert the data in it. Okay, and if show table command return that this table is existing, then it will not go to create the table again. It will just insert the data in it, because in append manner data is continuously get appended, right? So let's execute and observe what are the steps executed in backend. So here we have executed write mode and it is done. If I go back to query history, so anything appearing after this drop table command is due to that append manner write. So here you see first what it is doing. Okay, we executed select start from process data also earlier in the console. So anything appearing after select start from process data is due to that write operation. Okay, so first it is doing show tables like this, because we are writing in append manner. So first it need to check whether in destination the table is available or not. If the table is not available, it will create that. We will see that later. So now first it is creating the temporary table to read the data from external stage. Then it is executing the copy into command. Then here it is creating the process data 1 table, which is basically our destination. Then it is inserting the data from our temporary table to our process data 1 table. And then finally it is dropping the temporary table what it has created. Okay, here you can check that process data result set you will be getting. If I execute select start here, or maybe select count start, if I execute, we'll be having 100 records, because considering Setosa and Farsi we have 100 records, right? Now suppose again I am executing this write mode. What will happen? Now the data will be appended, same data. So now if I execute select count start, it will be having 200 records. Okay, right? Because in append manner data get continuously appended. So this is how using SnowPark you can read the data from S3 if the file format is CSV and write in Snowflake table, right? Obviously with other data frames also you can work with, whether it is Parquet, Avro, ORC, JSON, etc. Different file formats we use in big data world. So how to work with SnowPark and those file formats we are going to discuss in our upcoming videos. So this is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.